All right, for our third line on the check your understanding, we're going to start with finding the greatest common factor of 30 and 10. So we'll set up our factor trees. And I ask myself what two numbers can be multiplied to get 30. And I know that 15 times 2 equals 30. Then I ask myself, is there a prime number? 2 is prime, so I'm going to circle that. Then I go to my number that is not prime and ask myself, what two numbers can be multiplied to get 15? And 3 times 5 equals 15. And then I ask myself, which are the prime numbers? 3 is prime, so I'm going to circle that. 5 is prime, so I'm going to circle that. So my prime factorization for 30 is 2 times 3 times 5. Then let's go over to 10 and ask myself what times what equals 10. 2 times 5 equals 10. Then I ask myself which numbers are prime and circle them. 2 is prime and 5 is prime. So then I come down here and write my prime factorization for 10, which is 2 times 5. Then I'm going to look for what common multiples they have and circle those. So they both have a 2 and they both have a 5. Then to find my GCF, I will multiply the two common factors, which is 2 and 5, and it will give me 10. So 10 is my GCF of 30 and 10. Moving on to the medium, we have find the greatest common factor of 44 and 60. So let's set up our factor trees for 44 and 60. Whenever a number is even, I like to start by dividing by 2 or creating a factor of 2. So 2 and 22 would equal 44. Then I find my prime factor, which is 2. Then I'll move over here and ask myself what times what equals 22. 2 times 11 equals 22. And then I ask myself, what are my prime factors? And 2 and 11 are both prime. So laying out my prime factorization for 44 is 2 times 2 times 11. Then I'll come over to 60, and we have 2 times 30 would equal 60. 2 is a prime number, so I'm going to circle it. Then I'll ask myself what times what equals 30. 2 times 15 equals 30. 2 is a prime number, so I'm going to circle that. And then I will ask myself what times what equals 15. And 3 times 5 equals 15, which are both prime numbers, so I will circle them. Then I will go over here and I will list it out. 2 times 2 times 3 times 5. Then I'm going to look for my common factors. We have 2 as a pair and 2 as a pair, but there isn't any other pairs here, so I'm not going to circle those. Then I'm going to list out my greatest common factor of 2 times 2, which would be 4. So my greatest common factor of 44 and 60 is 4. All right, for our spicy, we're getting into our 3 numbers. So let's set up our factor trees. We have a factor tree for 40, we have a factor tree for 85, and we have a factor tree for 105. So first, let's go to 40. So 2 times 20 equals 40. 2 is my prime factor, so I will circle it. Then we're going to break down 20 into factors. 2 times 10. 2 is a factor. And then we'll break down 10 into 2 factors. So 2 times 5 equals 10. And both of these are prime numbers. So I found my prime factorization for 40, which is 2 times 2 times 2 times 5. Then let's go to 85. I'm going to start with, I see that it ends in a 5. So I'm going to start with 5 as a factor and ask myself 5 times what equals 85? And 5 times, I think, 17 equals 85. And we're going to double check that is 5 times 17, which is 85. So now both of these are prime numbers because they can't be broken down any further. So I'm going to circle both of them. And 85 is 5 times 17. Then we're going to go over to 105. And I know because it ends in a 5 that it can be divided by 5 or have a factor of 5. So 5 times 21 is equal to 105. 5 is a prime number. 21 can be broken down into 3 times 7, which they are both prime factors. So we are done with 105. So the prime factorization of 105 is 3 times 5 times 7. Now I'm going to look for my common factors. I don't see any other 2s. I do see a 5, but I don't see any other numbers. So my GCF is 5.